Hello, and in this video I will show you this emission properties for the breeze component. And first of all, I want to mention that there are two types of debris. First one is burst, and second is debris by distance rate. So burst means that every fragment will emit debris just once, and distance rate means that if fragments will start moving around scene, then it will emit debris over its simulation. So first let me show you difference. And in this first in the left example, I'm using only burst for this demolished rock, and for the second one I defined here distance rate. So as you can see, burst type set to none, but distance rate set to 2. And in this case I have distance rate 0, but I have defined total amount burst type set to total amount instead of none. So you can see that when this rock was demolished here with burst, it's emitting some fragments right away, instantly, and basically that's it. You will not get any more debris. And in this example, I'm using distance rate, and as you can see, there were not any debris when fragments were demolished, but it started emitting debris while all the fragments fall to the ground. So the best way is to use both these types. In this example, I'm just showing you the difference between them. So again, first one, emit debris just once, and then second, emit debris all over its simulation. And now I will show you burst types. So there are there are 3 burst types: total amount. Again, in this case, I defined my burst type to total amount, and my burst amount is set to 100. And this means that when this fragment will be demolished, and it will create some fragments, it doesn't matter how many fragments there will be, they will share this 100 debris among them. And if you'll, let's say, have 10 debris, every debris will have about 10, every fragment will have about 10 debris particle. If there will be just 2 fragments, every fragment will have 50 debris particle. So in this way you can define the amount of debris for all the fragments. And now let me create, just to show you. Again, so you can see I have set here total amount to 100, and I'm demolishing here. And now you can see here I have these fragments of this demolished rock, and every fragment has its own particle host. And here you can see in emission every fragment has, like this one has 9, and let's say this one have 6, and they share this 100 debris, depends on their size. So if it's small fragment, it will have less particle debris. If it's a big fragment, let's say this one, let's check it, and in this case you can see it's 12. So total amount of all debris will be 100. So this is how total amount works. In case you want to have exact amount of debris, you need to pick total amount for your object which you want to demolish. In second example here, I set it to per 1 unit size, and I set burst amount to 20, and this means that every fragment will generate debris depends on its size, and the bigger will be object, it will measure, every fragment will have its own size in units. So let me demolish just to show you. So here you can see demolished fragments here, and here in rigid component you can see its size at 1.67, and this one have 1.27. So since I defined my property here in the debris component to 20 particles per 1 unit size, depends on how big the size, it will create, let's say this object size is 1.27, it will multiply to this burst amount. So total amount will be about 25 or so. Okay, exactly 25 particles. So in this case you will not know how many particles you will get, because it will depend on how many fragments you will get, and how how big they will be or how small. So, but again, just another way to define particles. So you will be sure that if you have small particle, they will not generate a lot of debris. So this per one unit size type is good if you want to demolish your fragments over and over again. So you can, the less they will be, the less particles they will generate. So in this case, you can be sure that you will not get a lot of debris by very small very small fragments. And the last burst type is fragment amount, and this is the simplest one. It just makes sure that every fragment will generate this burst amount particle debris. So again, I set here 15, and when my rope will be demolished, you can see that every fragment has here burst type set to 15. So again, if you know how many fragments you will get, if you know that there will be pretty the same size, and you just want to be sure that every fragment will generate some exact amount of particles. This is this is burst type you need to use, just fragment amount here. But default one is total amount, and I guess this is the best one, so you will be sure that there will not be more particles than you defined. Okay, next property is distance rate, and as I already show you, it allows you to generate debris while a fragment is moving. And I have three different setups here. So all properties exactly the same, except that it's distance rate property here. That's the burst rate is set to 0. So again, in this example, I set it's to 0.5, and you'll see that. Okay, let me create first. So you can see the bigger this value, distance rate, the more debris you get. So as you can see in this example here, we set it to 0.5, and we have a very low amount of debris. And the next example I set here to burst distance rate to 2, and we have like average amount of debris. And in the last example I set my distance rate to 5, and we have a lot of debris in this example. So pretty straightforward property. The higher the value, the more debris you will get. Okay, and next property is duration. It works only for this. For distance rate emission type. So because burst type emit debris at the start just once, and since distance rate generate debris over its path, it depends on how big will be the duration of this emitting. So if you want to emit some debris particle over simulation but then stop, this is a property you need to tweak. And again, I have three references. For this first one, I set duration to 0.5 seconds. Next example have 2 seconds, and the last one have 5 seconds. So obviously, first one will generate debris for half a second and then will stop. And that's it. And second example will generate debris for 2 seconds, and the last one will generate debris over 5 seconds. But since my simulation is pretty quick, there's not big difference here. But you can see while I'm moving it, it still generates debris over some time. Okay, next property is lifetime, and this is the property which where you can define how much time your debris will stay in scene. Again, pretty simple property. It measures in seconds, and first one will define minimum amount, and the last one maximum amount. So in this first example, I set my lifetime for particles from 2 to 3 seconds. In second example, it's set to 12 to 13 seconds, and the last one set from 2 seconds to 13 seconds. So which means in this example, they will start disappearing, but it will take like 11 seconds. In this previous example, they will will fade away pretty quickly. In this second example, since I set life to 12 and 30, they also will fade away pretty quickly, but they will stay in scene for a longer period. So now again, let's take a look. So here you can see in this example, okay, you don't see anymore. And in this example, they slowly fading over this 11 seconds here. And here you can see also they stayed in scene for 12 seconds and then quickly were deleted quickly. So this is how lifetime property works. And then finally, last property here in the mission group is size. Again, pretty straightforward property. It allows you to tweak your size of your debris. If you don't want to change your reference size, you can basically scale your reference in case you want to have bigger debris. But if you just want to have some variation and you don't want to change actual debris reference, this is where you can play with size property. So this is just a multiplier. Again, I have 3 examples here. First one set 1 to 1, which means it will be exactly the same or size, have the same size as this debris reference which I'm using. As you can see, very small object here. In second example, I set it to 3 to 3, which means it size of debris will be tripled. And the last example here, I have some variation from 0.5 size to this tripled size. So the best way is obviously to use some variation. You can use some lower value and some bigger value, so you will get different debris size, but it depends on your actual debris reference size and fragments, so it will not look weird in case you will have debris with the size of the fragment. So you can play with this property here. Again, let's take a look. And again, you can see in this case I have debris, they all have the same size, and this not looks good, to be honest. And this looks even worse because they also have the same size, but they're just too big, because I have this triple size for all the debris. And here is the best one. In this case, you can see I see here small debris and big debris. Also, I'm using this orange material just to show you, so it's better. You will see the debris. It will be easier to see debris here. So the best way again is to use size with some variation, that like 0.5 to maybe 1.5, so they will not all look exactly the same. In case you just use one debris reference, because you can have several debris references with different size. And again, well, it's up to you to decide how it should look like. Okay, that was emission properties here, and thank you for watching.